All right. Class 5. We only did one chapter this time. We've been doing 2. I think last time we only did 1 as well, but this one's actually over functions, where there's actually chapters 10 and 11. They go over slightly different things, but functions is so important that we're going to slow down a little bit and just really focus in on it. I was going to do a demo of a completed liftoff project, because this week I've been hearing more and more rumblings of, what am I even doing? Why am I doing this? And getting very discouraged. So anything I can do to encourage people, which I've tried whenever you guys have been in the study rooms, and I've been trying to be encouraging. So if you need words of encouragement, reach out to me, or anytime you see me online, just I want you guys to feel successful. And still be here and stay with this until the end. So if I have time, I will do that, but I did not have that up and prepared because so many people had also amazing questions over the examples. So I don't know if I'll have time this time, but if I don't, then I'll definitely have time next class to show you a final project. Main things here, you're going to be able to use and describe functions, parameters, and arguments, and then being able to identify scope. So key takeaways, there are some vocabulary words that I will be using that you will be using for the rest of the course. Functions, so it's a section of code that you have declared as a function. A method is very similar, but it's usually attached to an object. So you usually perform a method on something, and a function is a type, or a method is a type of function. There's some key vocabulary, encapsulation, abstraction. To be honest, this one for me is really, really hard to distinguish between the two, but then I found some a good website somewhere that explained it to me. So the whole purpose of encapsulation and abstraction is to make it so that when I say console log, and then do something, I don't have to worry about the console. I don't care about the log. I don't really care how it's doing what it's doing. I just know that it's doing what I want it to do. So whenever we're talking about not code, but real world, the easiest example I can come with is, when you go to the sink and you turn on the faucet, there are a lot of things that happen to make that water come out of that spout. I mean, there's the water plant, there's the gravity, there's the pressure, there's your pipe, there's valves, there's all this kind of stuff. If you have hot water, it's going through a hot water heater, all these kind of things that make it so that you can just get water in the sink. And all of those things matter, but do you need to know about all those things to use a faucet? And you don't. You just need to know how to turn on the switch. So that's the same thing when we're doing code. When you do console log, there's so many people that want to get fixed in on, well, how does this work behind the scenes? And if you have time and the motivation, that's fine to go back and look at those things. But to be honest, if you can start going down the weeds and spending all your time on things that will not really propel you into a good place for becoming a software developer. So just understand that there's several types that we wrap around things and we say, just don't worry about it, just use it. And so that's the whole premise of this encapsulation abstraction. What I did see what the difference was, abstraction, I guess, is the design level process on how you're going to reduce the complexity, where encapsulation is the implementation level kind of that abstraction. So they're very similar. Abstraction is kind of the broader concept, and encapsulation is how did you actually provide that abstraction. And then scope, we'll get into a little bit later as well. Parts of a function, these are other vocabulary things that you do need to know. You need to be able to call a function. You need to be able to pass in arguments. You need to be able to use parameters and know the difference whenever somebody says an argument versus a parameter, because they actually tie very together. Like you can't do one without the other. But then return statements, that actually has the keyword return in it, but then the return value is the thing after the return keyword. It's the value that you're passing back, and then the body of the function. So we're going to go over that. They also talked about how to write a good function. I don't think that they gave as many details as some of you would like, because I was hearing a lot of things of like, how could I make this better? Well, all they're doing is they're talking about the structure of a good function. They're not talking about what goes in the body of a function. So just know They're not going to tell you how to make a good body of a function. They're just talking about, well, how do you know what to put in the header? What arguments and parameters should you be looking for? What should you be returning? So the structure, not the inside stuff. Scope of variables is very important. And then naming your variable or naming your functions. Functions are usually actions. So usually you're going to use verbs whenever you do these. So we'll get into some, but make, create, those are verbs. You also use camel case, just like normal. And then whenever you are doing functions, if you ever say that it is going to do two things, I can't think of one off the top of my head, but if you're going to say it's going to do this and this, you should actually be doing two different functions and calling them separately. So just know that functions, you want small, one thing. Right. What is a function? This diagram from the textbook is exactly what it is. You have an input, it does something, and there's an output. The function is the inside stuff, but once we get the function working the way that we want to, we should never have to look at that code again. It just kind of goes somewhere, and then we just call it and use it over and over again. Just like console log, they don't have to rewrite what that function does. It works. So once it gets working, they just keep using it. The definition from a book is the function is a reusable, callable piece of code. Examples that we've already used are console log, number, index of. Remember, if it is a function, it has to have the parentheses around it. It will always have the parentheses that's telling everybody that it's a function. And then a method is a function that belongs to an object. Meaning, in the console log is a method that belongs to the console. So you can't just do log, because then it doesn't know what that is. But if you do console.log, so the .log means log inside the console. Parts of a function. So these are definitions that I want to make sure that we're good with. There's my pointer. A function call, sometimes called an invocation. I'll always just call it a function call, is whatever the function name is with the brackets. And if it has an argument, you put it in there, but the main thing I'm looking for is the function name with the parentheses. That is a function call. The arguments or the inputs are what you put inside. It's the actual the variable value that you want to use. So the Philip is the value that I want to use in this function. The function name is the same thing as the function call. You call it by its name. My name's Philip, so I'm not going to say Steve to get my attention. So you have to call it by its name. The parameter is the variable that is holding the argument. So that's what I was saying earlier. Parameter and argument are tied together. Argument is the value that you're throwing in, and then parameter is the variable name that you will use throughout the function. And then the return statement is the whole entire line, return. And here, there's actually two return statements. The return value is the value. So just be the text inside. And then the function body is everything inside here. So the function body is all of this. So, this is just straight from the textbook. I'm going to put my little twist on it, but that's it. There's 3 steps that they said. They said to design your function. So what do you want your function to do? And these are the 3 things that you're thinking about. How are you best going to name your function? What type of things are you wanting from your function, meaning value and type? And then what kind of parameters are you going to need to be able to do that thing? such as whenever you're making a sandwich. Well, at the end, I want a sandwich. So my return value and my return type of this function, my return type is going to be a sandwich. My return value is going to be the value of that sandwich, whether it's a bologna sandwich or a ham sandwich or a pickle and cheese sandwich. It doesn't matter what it is, but the value, I'm trying to think, what kind of values do I want out of this? But more importantly, what kind of type do I want? And I want a full entire sandwich. Well, to make this sandwich, what things do I need to make this sandwich? Well, most sandwiches have some kind of bread type. They have some kind of thing that goes in the middle, and then they might have condiments. So those are the key things that when I'm thinking, when I go downstairs and I make a sandwich for myself, I'm going to get some bread. I'm going to put peanut butter and jelly. I don't know if that's a filling type or a condiment, I guess. But hopefully you'll get the picture that you're wanting to develop something, make something, and you have to think about what is my end result. And if you see, that's my actual first point here. When you're designing your function, the first thing that you need to be thinking about is what do you want at the end? And then you work backwards. What is it really doing? And so then what do I need to make it work? Okay. And then lastly, you just need to write your body. The problem is several people were like, they were hoping for more advice on this, but everything is different. Making a sandwich is way different than making a square out of hash marks. So there's no real good one way to write the body. The biggest thing is you have to return something if you're expecting it. I see too many people forget to do the return statement. So, okay, scope. The scope of a variable is where the variable is visible in the program. So I'm going to do some live coding to kind of show you that. In particular, if a variable is defined using let inside of a function, it will not be viewable outside the function. So some of you on your graded assignments had a problem with this because you accidentally put something outside the function. So the curly brace at the end of the function was like a line above, and then your console log was outside the function, and you had some weird oddities there. So make sure that everything inside the function deals with inside the function, and then everything outside the function is not dealing with that function. But what's weird is if you have something and you declare it inside a function, you cannot see it outside of there. But if you declare a variable outside, so on your graded assignments, we're doing like the let candidate answers be on the outside. Is at the very top on the very left side. It can actually be seen inside those functions. So if it's, and we call that like a global scope is when it can be seen by everything, and like a local scope is when it can only be seen locally. Why create functions? So great question. Order of parameters, it does not. The only thing that I would take in consideration is readability. So I usually go in the order that I care about using them. So if I'm going to need that first parameter first, I'm going to actually put it first in the list. What does matter, and I didn't think about putting this in there, if you have two parameters, it does matter the assignment of the arguments then, because the first argument will be assigned to the first parameter, and the second argument will be assigned to the second parameter. So it doesn't matter which order you set up your parameters when you're building the function, but then keep those in mind whenever you do call the function. The whole reason we do functions, reduce repetition. So as you went through the exercises, you're like, I'm calling this make line over and over again. Yeah, that's so that you don't have to repeat that code again. You can just call that one thing over and over again. Readability, whenever you name your function correctly, I can just call it, and people don't have to like search through 20 lines of code, because whenever I get to this one line, it says make square. I'm like, oh, I know what that does. I don't have to go reread through code and then indent more things and get 100 lines of code at once. I can just say, oh, it makes a square, it makes the line, it reverses things, it makes readability a lot better. Reduce complexity. Whenever you really start getting into coding, this should not be on the front part of your brain, but it should be like as you get better, you should start seeing where you can separate things and then break them apart. So whenever I give you, it's like giving you 100 problems to do all at once versus giving you 10 problems, letting you do those, giving you another 10 problems. Which one's more complex? Well, as soon as you see the 100 problems all at once, your brain goes on overload and it just seems overwhelming. Where if you see this little bit and then you can go see this little bit and you're chunking it out, it makes it a lot less complex. And then code sharing, I don't have a good example about on what we have done so far with code sharing, but it is similar to the console log. If you can make that assumption, somebody else wrote console.log. Somebody else wrote number and allows us to change into numbers. Somebody else wrote that, but we get to use that. So that's what it's talking about code sharing. If you can, capture just that one function, then all they have to do is call that function. They don't need the code as long as they're pointing to where it goes. So that console.log is actually in a library somewhere in Node, and so Node knows what it is because it's so common. But again, going over, making sure that my lectures aren't too long so that we can get into live coding. And again, expectations. Make sure that whenever you're in studio, you get this, the attendance code, and then turn in your studio. Make sure you're reading and doing your exercises. And then the biggest thing right now is the final graded assignment part is due on Monday. I'm just going to throw out there, I will probably be online Friday after work. I don't know how much I'll be on Saturday. I'm helping with a local Django Fest coding Python something Saturday, so I don't know. It might be here or there. But then on Sunday, during the Chiefs game, I'll at least keep an eye on my computer. But obviously, I got to watch the Chiefs game. So, if I have time, I'll show you that. But that's not going to be right now. Live coding, I think that's it. Yep. Let me switch over to live coding. Some good questions while I'm pulling this up. Can the same parameters names be used in different functions, or is it better to have different parameter names in different functions? That's a great question. As long as you keep them consistent, meaning in your mind it's easy to track, I absolutely use the same ones because like length and height, kind of like you stated size, height, I'm going to use that over and over again. So I used height in make isosceles triangles. I used height in make diamonds. I'm using height all over the place. But that's where we talk about the scope. This height here, once it hits the end of this function, and I will zoom in a little bit, once it hits the end of the function, it just disappears. So I'm actually questions. Okay. I think this is how big I usually have it. Is this fine? Okay. So on this, I actually did the exercises. These are how I did it. I think sometimes mine in the book are the same, and sometimes they're not. So just don't look too much into it. The key thing that I wanted to talk about here is it's function calls. So if I go down here and I say node, this is called exercises, and I run this, nothing happens. But I have 74 lines of code, and it's not doing anything. Well, I made things here, but it's not doing anything. So the first thing I got to realize is functions only happen if you call them. So as the computer reads line 1 and reads line 2 and reads line 3, and then it gets to line 4 and it says, oh, here's a function, it does not execute this. It does not execute this function because it knows the keyword function means that I'm going to save it for later. I'm not going to do it right now. So when it doesn't do this line, it doesn't do this for loop, it doesn't return anything. It does not do this. It just takes note that there's a function here. And then as it goes down, it's like, oh, there's a function. I'm going to take note of that so that I can look back and reference it later, but I'm not going to run any of this. I'm not going to run this. I'm not going to run this. I'm going to keep note of it. I'm not going to run this. So when I look at my code, there is nowhere in here that I tell it to run anything. That's why whenever I run it, nothing happens, because I never told it to do anything. The other thing to think about is what I like about VS Code. Anytime you have a function, sometimes the code gets a little too long. I sometimes close these. Now, I only close them once I'm done with them, so I don't like purposely close this before I make the middle of it. But if I close these, it helps me figure out that there's nowhere in my code right now that I ever called one of these functions. That's why it's never working. I never called it. So for me to call it, well, let me call it and let's see. So make line and the size is 5. It still doesn't print anything, because that's another thing that some people get confused about. They're like, I said to make a line. Inside my make line, I'm making a line and I'm returning it. Why doesn't it show? So computers do exactly what you tell them to do. This return says, I'm going to take this line, whatever this variable is, and instead of having a make line 5, I'm replacing my make line 5 with whatever that line is. I still never told it to print it. So make sure that if you're expecting something down here in your console, that you have to say console.log. But now when I do this, I get my 5 hash marks. And again, once I have made it, I can just close this up. I don't care about how it works anymore because I made it to work exactly how I said to make it. So now I can just forget about it and move on to my next function, which is, well, it was make square, and I used the make line function. And then it was the make rectangle, and then it was the make square. What I want to just call out, and then I'm going to go off to my own stuff, and I might come back to this depending on what it is. The make square, when I originally made this, it had lots of lines of code. There has been some confusion that there's only like one right way to make code. And I think I said this before, but I'm going to reiterate it, I don't know how many times. If your lines of code do not look like mine, but produce the same exact code, it is correct. Now, there is a different thought of, is it better code? Is it cleaner code? Is there such thing as better code? And there is. But whenever you say, is it correct? There are multiple ways to write code that is correct. So just making sure that at your guys' stage, as you're coming in, your step is to make it work. It's not to make it look pretty. It's not to make it only do one line, because some of this I could probably clean up. There are ways to do for loops with arrows that do all of this stuff in less lines. There are multiple ways to do this that more advanced programmers would do. That's not you. Your goal is to understand what you are typing and get it to do the thing that you're getting asked to do, which is in this case, make a square. Because it was asked, I will go ahead and run this. So I'm going to do the console log. I did this, yeah, there's a couple people that I did this in front of, but they made it sound like it was good, so I'll do this again. So whenever I run this console log, I should get a rectangle that looks like this. It's 4 hashes by 6 rows. So the question is, do I really need this slice? And you actually don't. So in my opinion, if I was walking somebody through this, I would not have this at all. Because does it give me a rectangle? What, like when I look at the difference between these two things that just printed out, there is a slight difference, and you need to know that there is an extra line down here. The question is, if I'm a professional programmer, that extra line is not my problem. That's my project manager's problem and the business problem, and they need to tell me, does the business requirements say that there cannot be a line, or does the business requirements tell me there's okay if it's a line? So at this point, as a beginner, you're not thinking about all this stuff. You will be told exactly what it's supposed to look like. So make sure that if you're looking at different things that the book says and you're like, my thing looks just like yours, I would be fine if you just left your code like this. Now, whenever you get down to making a diamond, that's where that extra line is going to be a huge problem, and you will have to get rid of it. But I think on all of these, if you just didn't use the slice and you did this, I would accept it 100% right. Now, some of you were wondering, well, what does this even do? So I'll explain that real quick. Whenever I go to the slice here, remember there's a start number and an end number. So the start one is, where do I start at? And remember, everything is 0 index. So it says start at the beginning and go to. The problem is, well, how many characters is this going to be? And it's going to be a lot. It's going to be, I don't know, 30 characters. But then if I change this number and did an 8, that's a different number. So I cannot hard code a number right here to say, this is the last one I want to stop at. And because other people have had this problem before, what they did was they updated this method, this slice method, to be able to use negative numbers, meaning that's how many you want to go back from the end. So whenever I say 0 to -1, it starts at 0, it uses the first element, and it goes all the way up until the last element, but does not use the last element. Well, in this case, that's a character. So my last character was these widths with this thing right here. So this character right here is the thing that this -1 is not going to look at. Here's what I do to play around with this. I might have had it somewhere. Nope, that's not it. I think I posted it somewhere. And I think I deleted it from here. If I can just make it up real quick. So if I said make a string, this is the exact one because I have no creativity. So sorry, you're going to see this again. This is the kind of stuff I do all the time. I'm like, how does this actually work? Well, let me hard code something that I know what it looks like. Let me print out something that I think it should be, and let me actually run it. I am going to comment this one out so we don't see the rectangle again. So I'm focusing on these top 2 lines. And if you look here, it's like, hello, hell. And that's not very good. So I actually want, I want it to go back like 5 spots because I don't want to see that. And it just says hello. So it goes back 5. 1, 2, 3, 4, 5. And you can keep changing these around to see what it really does. The only oddity to the new line thing is, and this is not like something that you're just expected to know. You have to learn it. Even though the \n looks on this program as 2 characters, because it's a special one, the computer recognizes it technically as 1 character. So yeah, those are only for special. If I would have done this one, those would have been 2 different characters. So because I'm doing the special character one, it's only one, the computer sees that as one character. There was a lot of typing. I'm going to assume that you guys are helping each other, and I'm going to keep going. Let's show you some examples. And hopefully, my goal was to make sure that you guys know the difference between return and console log. Console log prints out to the console, return does not. Return takes whatever was done in the function and puts it where you called it. It does not actually print out anything. So I'm going to delete that. Okay. I think this one was in the book. So I'm going to go fast because this was in the book. Hopefully you remember this one. Remove hyphen. Guess what? Do you know how many times I actually looked at what this did? I actually didn't. I was like, oh, somebody else made this. Oop. I know what it's supposed to do. It's supposed to remove hyphens because that's the name of it. So I'm gonna go right here. I'm gonna put a phone number in. I'm gonna say, hey, remove hyphens from this, and then I'm gonna run my file. And as you can see down here at the bottom, it removed the hyphens. And as long as it worked, I don't need to look at the code. That's cool about functions. You guys are also beginners, so you guys are writing functions, but I'm letting you know. So my first software engineering job, I go in and there's over 1,000 files with multiple hundreds of lines in them. Nobody is expecting me to memorize all those lines of code. You will never, there's nobody on my team, even the ones that have been there for 6 years, that knew every line of code. What they did was they hoped that the person before them named their methods and named their objects and named their variables really well. And we took that assumption because if I actually read every single line of code to do my job, I just couldn't do it. So I got very good at, if it says remove hyphens, I'm going to believe it until I prove it wrong. And so if I would have ran this and then it did not remove the hyphens, that's when I would be like, it says it's supposed to remove the hyphens. Why didn't it? And then I look at it. So you guys are still at the beginning stage that you're writing functions, but that's to the level that you want to get these at, is like, I'm writing a function and whatever this name is exactly what it does. And once I write it, I don't have to look at it again. I just call it. Then the question was, and this goes back to scope. When we did this, it said error. And it said, this variable, string without hyphens, is not defined. And the way that I have shown this right here, I don't see it. It's not viewable, right? It's not viewable to me, this string without hyphens. But if I look inside the function, there's string with hyphens. There it is right there. This is that scope that they were talking about. If I close this function and I cannot see my variable and then I try to call it, your computer will not see it. As soon as it starts this bracket and then gets to this closing bracket, everything on the inside, it forgets. If I assigned this on the outside, it would see it. But that's because when I close my function, even though I'm using it on the inside, the visibility of that variable is on the outside. So when I call it here, it's like, oh, you're talking about that function, that variable that's up there. Hopefully you guys play around with this just a little bit more to make sure that it sinks in. I'm not expecting you to be like, oh, I definitely know what that means right now. But hopefully that triggered some thoughts. That wasn't helpful. Where if it is inside the function and I close it, And now when I look at this, because it hasn't ever seen that before on the outside of the function, it doesn't know what that is. That's about scope. I'm gonna do that. This was a thing of clean code. I thought this was a good example. There's no actual functioning code. If I wanted to make lunch, I could have put all the code for the sandwich and all the code for the drink inside this function of make lunch. But because make lunch, what does it mean to make lunch? Well, make lunch is to make a sandwich and make a drink. And remember when I said when functions are called, they're only supposed to do one thing. So if making lunch consists of making a sandwich and making a drink, I should not put both of those in there. I should separate those, have make a sandwich one thing, make a drink another. I think this was also a thought exercise on what parameters you could potentially put in for each of these. I'm not going to go through that, but I just wanted to call out whenever you're naming and doing these things, make sure that if your code is doing more than one thing, it needs to only do one. Since the graded assignments on everybody's brain, this is exactly what's going on with the graded assignment. Did you see how everything was in functions? They asked the candidate's name, and that was the only thing that function did. It was one thing. There was another function that was asking the questions, and that's all it did. There was another function that was grading it. It's only one thing. So make sure that's how you're supposed to write functions in code, is making each function do its own thing. And then you can have, like they have, is the run program or run function, I think it's run program. You can have one function that calls all the other functions. That's fine. But itself isn't doing anything except handling all the function calls. So, chain methods in a function, it is not advisable. It's harder to see where things go wrong. And then also, whenever you chain inside, this is a memory. Okay, maybe this might make sense. Okay, I'm going to talk about something that is above the level of this course. So if don't think you have to memorize what I'm saying. But let's say that you know that after you make a sandwich, you have to pour the drink. So instead of it being like this, you put it inside here. And so you're saying, do this one, then do this one, and then do this one, right? The problem with this is in computer science, in very high level, like this is like making a sandwich is super easy, but let's say I'm calling 1,000 different functions. Remember when I said when a function is done, the computer forgets about it? That's very important because right here, when I make a lunch, when I make a sandwich, it's going to go up here. So make lunch is still open. Make a sandwich gets open. And then once I'm actually done making the sandwich, I have to pour a drink. So make sandwich function is still open while I'm pouring the drink. So the computer's memory, it has to know all three of these functions at the same exact time, like they're all open at the same time. But if I do it this way, as soon as I make a sandwich, the computer forgets about everything it did inside make a sandwich while it's making a drink, which then gives more resources, more memory for it to do what it needs to do. So I know that was way deeper than what we needed to do. So if you didn't catch any of that, do not worry. Hopefully a couple people did. This is that function that I had in the example. I just want to make sure whenever I'm calling this variable, or this argument gets put into this variable, which a variable of a function like this is called a parameter. And as I highlight over it, it even says that parameter. And then it uses whatever I say here inside this function. So I think I've already went over enough of that for me to keep going on. Mm-hmm. So the question is, if you're making something case insensitive, is that calling something? Technically, no, it is not making your function do something, because as soon as it runs, it'll get why it. Don't overthink that. And I probably will not go into callback functions in this lecture. So I know briefly what they are. I'm not prepared to speak to them right this second. Okay. The other thing, I don't think this was clearly stated in the book, but maybe it was. I can't remember where I got this. Maybe it was. Whenever you return, anything after that return will not run. So if I say run this method, it's going to say, oh, I know what that function is. And then once it hits this return line, it's going to be, this function is going to be done. So just to clarify, even though I said console log, this will not be printed, it does not print, not because I used the word this does not be printed, but because this doesn't matter what I type in here, it's still not going to run. Once it hits the return statement, it's done. That comes into effect with that is true function that a lot of people were wondering about, because once I return true, it doesn't even look to see if it's false, because once I return, it's done. So I did get this from the book. All right. I can't remember, to be honest, why I wanted to do this one. I think it was the because this one was an odd one. Was this one also from the book? So if you just say return like this right here, it'll just stop. If you tell it to print it, it'll print undefined. So that's a good question. So if I said count to n, and I said 5, it'll print to 5. Now remember, line 72 is not doing the printing. The printing is being done by line 67. So the 1, it's because it's 1, and then it goes up, and then it goes 2, and then it counts up, and then it's 3, and it counts up. But this is a good question of like, remember there was breaks. So if you're in a function, sometimes you can just return to kick it out. This is not a very good use case, meaning most of the time the reason you're writing a function is to do something to something and then return that new thing that you just did. So this is, I have seen this, and there are use cases for this, but don't go to this one as the default. Then the question, like you asked, is what if I do console log? So this is printing what it is going to return, which we said here, it's not returning anything. So when it doesn't return anything, it's undefined. So when you try to print it, it's undefined. Okay. All right. I wanted to re-go over. I'm not going to go over these in detail and run them. This is the perfect example of how you're kind of supposed to think about writing a function. That's why I like this one. Not because of the actual function, it's the progression that they took. So if I ask somebody right off, like if that was like a test item, hey, write a function that prints true if the number that it's given, so the n, is even, print true. If it's not even, print false. This is probably the first thing even a mid-level developer is going to think in their head and potentially write out. This is absolutely perfect. again, there is such a thing as what's the cleanest code or what's the best code or what's the whatever code. And so somebody could say, well, that takes up, that's 7 lines of code. Can we do it a little quicker? And we could do this one. Now, the difference between these two is not much because the computer consumption of an else is not a lot. Now, if this was another if statements take computing power, else's really don't. So I'm not too worried about these two, but it does clarify if it's true, it'll never hit this false because once it returns true, it's done. And then if it hits false, it's done. Same thing here, though. It's same thing. But then it's like, oh, this, how can I do this in one line? And then if you guys know anything in the Boolean, so this creates a Boolean. So if statements have to be either true or false. So this statement by itself is either true or false. So you could just return this because if it's true, it'll return true. When it evaluates it, it'll be false. So this is, don't worry too much about if you would have gotten to this one, because I think at your guys' level, I'm not expecting you to be able to do this third one on your own. I am expecting you to understand that your code might look like this, and then either the book or your friend that's a developer might have code like this, and that's perfectly fine. So let's go over some vocabulary. Let's go over equal sign because somebody's asking about it. If I say color, which I have not defined here, this is a thought, not true code. So just know that this is not code I'm going to run. This is more for thought, but I'm clearing everything else out of the way. Let's say that color is a variable, and I said equals blue. This line, when executed, is going to set my variable color equal to blue. That's what this line does. If I do either 2 or 3, I'm not going to show the 3, but it's the same thing. 2 or 3 equal signs. That is something different. This sets the color to blue. So anytime I use color after this, it'll be blue. This one is asking a question. This one is asking, that color that you're talking about, is it blue? So whenever it asks a question, the answer is either yes or no, because computers can't do maybes or kindas or whatever else. This is a yes or no question. Is the color, whatever that is, and of course, this is more of a thought thing, is the color blue? Yes or no? And the computer interprets yes and no as true and false. So as soon as you do a 2 or 3 equal sign, this statement here will return either a true or a false. Hopefully that clarifies a little bit. That is something that you do need to like that has to sink in at some point. So like I'm not expecting you to always remember that and be really quick about it, but you do need to know the difference between 1 equal sign is setting something where 2 or 3 is asking, is it that? This one is the one that I was a similar thing. So here's a palindrome. This was in the book. It's saying let the reverse, and then it's gonna. Here's that triple thing again. It is not going to return the string. It's not going to return the string that's reversed. It's asking. This is asking a question. Is the reverse, whatever I created here, is it the same as the string that was passed in? So this right here is either going to return true or false. Asking. The question is, I could do this one. I didn't put in my separator. No. Okay, yes. So the palindrome is this one. My question is, if I did this one, which one is better? And there's actually not a right answer. Versus this one. This is more lines of code. So if my objective is for lines of code, this as a whole is 2, 4, 6, 7 lines of code. This one here, if I squeeze it all together, is more than 7 lines of code. I think it's 10 lines of code. So this one must be better, right? Because it's less lines of code. The question is, either one of these is right. Absolutely. This one is saying, is palindrome, the is asking a question. It's asking, is the reverse of the string equal to the string? And then the reverse, the actual calculation of reversing a string is separated. So all of this stuff above is pulled out and done here. And then just the asking part, the return, is pulled out here. So these are, you can debate either way, and that's what I'm going to throw out the pros and cons. If I only care about is palindrome and it's only going to be used once or maybe twice, but it's always going to be a palindrome, this one's the best in my opinion. If there is any other reason that I want to reverse a string, even if it's not a palindrome, this one's the better one. Because I can use this reverse function on anything. I can also use this reverse function on the diamond. I don't know if you guys got there that far or not, but on the exercise, there's the triangle. And if I reverse it, it's the downwards triangle. So if I put this function inside my exercises, and I got this from the book, and then said, make the triangle, and then take that triangle and reverse it, it does my diamond. And if I had this function to do that, then I would make my is palindrome just that one, because that would be the better one. It'd be a one-liner. So there are pros and cons. There's always negotiations happening on which function is better. That's perfectly fine. You are, again, I'm going to go back to, if you've never programmed before, your expectation is get it to work. I don't care exactly how clean it is. Now, if you have time after you get it to work to start working on cleaning, and we call that refactoring code, absolutely do that and get better at that. But do not sit there and think, well, I'm a horrible coder because I saw somebody do something in one line when it took me 10. That doesn't mean that you're better or worse. It's just different. So to incorporate this one, it has to be in your code. So if I wanted to use the reverse function, I'd go over here, and for my diamond, of course, I already have a reverse function, but you have to just paste it in and then call it. So you can't use it unless if it's in there. Let's keep going. Oh, okay. This is the one. So this is also the difference between Java and JavaScript. If I had this in Java right now, it would be throwing errors. So IntelliJ would be like, you're doing something wrong here. And that's because the function that I'm calling, this hello function, has a parameter. So it's expecting something, but I'm not passing it in. And JavaScript, I just lost my console. This function is expecting a name to go in, and because it does not have a name, it'll just say undefined. So JavaScript at least will not error out, because in Java, this would say, hold on, I'm not running this code. So tightly, like strictly typed languages, and really, and that's also because it's not it's a compiled language. So it actually like pulls together and does all that stuff even before it runs. So we'll get there when we get to Java, but this would never happen in Java. But if that happens, you know that if you type something in, then it'll work just like you want to. Do I have time? Yes. Okay. I have a little bit of time here. This is more advanced, okay? Because some people were, I got on that MDN thing and I was looking at arguments and parameters. And again, this doesn't happen in Java. So you can see me smiling because it's like, I never would have thought about this because I don't work in JavaScript all the time. But I'm going to call this function, and this isn't in the book. I'm going to even zoom in so you guys can see a little bit better. This is not in the book. I made this function and I called it, and I have the parameters of A, B, and C. So A is going to be 1, B is going to be 2, C is going to be 3, and this 4 and 2, in most languages, these would just not either be used or cause an error. But this one, it actually, like on this line, it calls them out. It's crazy. I still don't understand JavaScript. I want things to be ordered. But just so you know, whenever you guys are going crazy and there's some JavaScript thing doing something, or you see some random code online that works and you're like, I have no clue why, sometimes it's just the language is made to be weird. So now I will explain this. So arguments, do you see how there's no arguments in here at all? Arguments are a key word, and it is often used. So in Java, we don't write the whole word arguments. We say args, A-R-G-S. So we can do the similar thing in Java. But arguments is like taking all the parameters, like all the arguments that are passed in. And remember, these are called arguments. So there are times that instead of knowing how many arguments that are coming in, because I don't always know, this isn't all the case, but there are sometimes you don't know. Oh, you can even see right there, args. There you go. That's the function. That's the variable that it holds. So all of these arguments get passed in here and actually get assigned to this special array, and then you can actually use them. So again, that's advanced. Don't worry if you didn't get that. You can technically, I think you can. We have a little bit of time. I like to play with these things. If it has a length, you can iterate over it. Yeah, it says it's 5. So yeah, you can take the length of that and iterate over it for the length of the array. It knows that there's 5, and then you can do that. There you go. Again, if you're like, I have no clue what's going on right now, it's perfectly fine. This is not part of the textbook. I do want to go over, I think, one more kind of advanced thing, and then I will get off my little soapbox of advanced things. We will learn more about these later, but I just wanted to preload this because it's in your graded assignment. Remember, whenever you go to your graded assignment, you actually have to run index first. Well, you'll see something like this where it's like, let this variable equal require, and then this is pointing to something else. So in your graded assignment, it's pointed to your candidate assignment, or I can't remember exactly what it's called, but it's pointed to a file. And if you look, it actually tells me exactly where that is. It's in my JavaScript projects, functions, try it, say hello. So it tells me exactly where this module is, and it assigns that module here. And then I actually have this say hello method in that file. So I'll show you that, but it's kind of cool how I can just do this, and it says hello Philip. And if I go here, this is my say hello, and I have a function called say hello, and this is where I've actually coded that at. The cool thing in VS Code, if I hold control, you see, if I don't hold control, it's just one of those. If I hold control, it turns into a finger, and then I can click it. It's one of my favorite tools. I go around and do things all the time, clicking things, seeing what they would do, and they go around to different places if I hold control and click. The reason we don't do this earlier, for me to be able to see this function, I actually have to export it. Which is another concept that we'll talk about. So again, don't worry about, we're not talking about that right now, but anytime you want to see another thing outside of this file and you want to use it in a different file, you have to export it in JavaScript. So, all right, let's go back to the normal stuff. This is where I was doing that. I knew I put it somewhere, that slice -1. You know what's weird is I might actually have enough time to show you that project. All right. Fine. I guess somebody said this question here. I want to clarify, making sure what they mean. Steve, I typed this in double quotes. Whenever I do single quote, Steve with no quote, the computer is looking for a variable. So whenever I run this, it should error out on me saying it doesn't know who Steve is, because it doesn't even know Steve is a who. Steve is not defined. Now, if I wanted to do wish I could type let person equal Steve, and then do a person there with no quote. What's really going on is it's saying pass in person. Well, what is person? Person is the string Steve, so that's what I'm passing in. So this one will work just fine. But it does, if you don't put quotes around something, it's expecting it to be a variable. I'm hoping that answered whomever's question. All right. Two other things I wanted to talk about. First of all, this string split reverse join. I am going to give away your diamond answer. Just so if you don't want to know how to do the diamond for me and you want to do it on your own, you can, don't put me on mute. Well, I guess you should have done it before today. There you go. If you didn't want to hear my explanation before you did it, you should have done it before. This is how fast the diamond thing is. You're going to let the diamond equal the make isosceles triangle with the height. And then you're going to add to that diamond the reverse of it. And remember, because in the make isosceles, right here, I cut off the last one of these. Because I cut it off, I have to add it in and keep going. So that's what this one's about. My reverse, though, is different than the books. My reverse is this thing right here. I don't know if you guys remember this. We briefly talked about this with method chaining. My S is a string. I can split strings. Splitting string makes it into a character array. So I'm going to just do the reverse function. The reason I'm doing this reverse function is I think, for the studio, you're going to want to know this. So you don't need the make diamond for the studio, but you do need this reverse function. You don't need it. It will help you dramatically in your studio. So that's where I pay attention here. If I say let something equal, and then I said console log because I want to print out so I can see it, the reverse of CR. Oh, that's the wrong file. I'm back in my exercises file. Where am I? I didn't, which which line is that on? Line 2. Well, that's not very helpful. I don't need that anymore. Now let's rerun this. Right. If you see it, it puts launch code backwards. So somebody already typed it out, but I just wanted to show you that it does work. And the str is a string, so the s is going to be a string, even though I'm not telling it has to be, but it will be. So once this string launch code gets split, it turns it into a character array. So remember, we did this with message chaining. It becomes L, A, U. They're separate, like they're all separate one character elements of an array, because I can reverse arrays. I cannot reverse strings, but I can reverse arrays. So then it actually turns all those character elements backwards, but it's still an array. And so then when I do the join takes any array and returns it back to a string. So I think we did this one in that method, in that chaining, but you'll want to make sure that you know that. And then I'm going to start just the basics of the studio. I'm not actually talking about the studio as much as just how to start some of these things. You are going to have to reverse characters in this thing. I just gave you half the answers right there, that reverse thing. The part that I want you to work on is the function writing, though. That's what's more important here. When it says define a function as reverse characters, if I'm going to write that out, defining a function says function, and then I give it a name. I have just made my reverse characters function. But my question is, what does it really want? What does it want in the end? Because I need to be able to return something. So I'm asking myself, what am I wanting to return? And similarly, I'm asking, what is it going to give me to do my thing to then return? So that's what you're supposed to be focusing on when doing these, is return and parameters. It's going to have one parameter, which will be the string in reverse, which will be the string to reverse. So it does not matter your name here. You can do str, but it's going to be the string that I want to reverse. So I did string to reverse. It does not matter what you use this, as long as it makes sense. Within the function, you're going to split, then reverse, and then join. I just told you how to do that. So you already know how to do all that from the middle. To create the reverse string, this is the string to reverse. So I want to return the reverse string. That's what I want to return. That's the stuff that we're trying to get, like, to learn in this section. I gave you the answer on the other thing. I'm not putting it all here together. That's for you to do in the studio. But that's what I'm trying to help you with, is making sure that you have a function, you have a name, you have a parameter, and you're thinking, what do you want to return? And then the middle part just depends on what the function is. So which one's not camel case? You're talking about the R? I don't like, I mean, I could do this. There, does that make somebody happy? All right. I'm going to see how fast I can get this up. I thought I wrote a function, a batch file. Not there. All right, I'm gonna go ahead and stop the recording part.